Αυτό, εντάξει, okay. Και θα υπάρξουν και άλλα πράγματα το απόγευμα, δεν θα είναι μόνο Chips Act η σημερινή εκδήλωση. Οπότε να καλωσορίσω τους καλεσμένους μας. I'm switching to English now because two of them not speak the Greek language, or at least one of them is trying. So let me introduce to you to Romano Hoofman from IMEC, and Mr. Victor Acinas, who knows very well that his surname sounds like Athena, and Mr. George Kotrotsios from the CSEM in Switzerland. So I'm going to start asking questions from Victor. Victor, you have been working with, first of all, you work with applied materials, and you have been working with EU projects for many years, based in Ireland, which is a known semiconductor hub in Europe. And you have seen both sides of the world, the academic and the industrial world. You have helped set up facilities in the Tyndall Institute in the south of Ireland. And I ask you, for the sake of our audience, to explain a little bit the global and European semiconductor ecosystem. I know Mr. Skordas already has done this, but once more, will help our audience get into grips with it. And also tell us about the connection of applied materials to Greece. And tell us whether, from what you see, Greece from Ireland, whether you might consider Greece as becoming a player in the European semiconductor ecosystem.
Thank you very much, Babis. As we have seen, the first step in the semiconductor value chain is the chip design of new chips, and this is done depending on electronic design automation software and also intellectual property from existing chip designs. Once these chip designs are designed, then they are fabricated, relying on semiconductor equipment, chemicals, and wafers. And finally, the produced chips are tested and packaged during the assembly process, also again thanks to semiconductor equipment and chemicals. Within this value chain, Applied Materials has been for over 20 years the largest semiconductor equipment provider. Applied Materials is currently providing equipment which is used to produce virtually every new chip in the world. And in 2020, we acquired a company in Greece called Think Silicon. They are focused on high performance and low power chip designs for specific applications in the areas of graphics and artificial intelligence. And the reason why we came to Greece and why we continue to grow and invest in Greece is because of the talent and the expertise that you have in highly specialized chip designs and software such as RISC-V architectures, or also mix and analog and mix chip designs, as well as electronic design automation tools. And it is this ecosystem within the chip design environment that where I believe Greece can play a strong role in Europe. In particular, there is a good opportunity at the moment for the Greek ecosystem in the area of design to become a strong participant of the virtual design platform proposed under the EU Chips Act.
Thank you. And moving to Romano Hoofman now. Romano, you have been working in the sector since year 2000 for Philips, NXP, and for the past 7 years you have been with IMEC. IMEC is perhaps the only chip prototype facility in Europe that startups and research institutes can rely on for the prototypes in advanced technologies. Can you give us a brief outline of IMEC's semiconductor-related activities, how these benefit the European and global ecosystem by pushing global technology barriers? And if you give us a brief history of how long did it take to make IMEC a successful organization? And finally, what is IMEC roughly planning to do with the CHIPS Act?
Yeah, okay. Thanks, Babis. Well, you understand that I like to speak Greek, but my Greek is not good enough. So, μου αρέσει μιλάω πολλές γλώσσες, αλλά ελληνικά πολύ δύσκολο. So I will switch to English again. That's much more comfortable for me. Yeah, IMEC is known, I would say, for most of you as one of the top R&D institutes. So big players from all over the world come there to our joint research programs. And we have two clean rooms, a 200 and a 300 millimeter clean room, where we do very advanced research. So we are always ahead of the roadmap. So we are researching, for instance, now 1 nanometer prototypes and even going beyond 1 nanometer. But IMEC is not known so much that we also help startups and SMEs with access to silicon, and that's what Babis is referring to. So we started actually many years ago, and it was already mentioned by Thomas in his keynote, with Europractice. So Europractice is a program that was started by the European Commission many years ago to support actually academics and startups to get access to silicon technology. So to help them with their design and then prototypes and scale up to volume. We continue to do this, not only under the Europractice program, but also in our department, which is called IMEC IC-Link. So we really help many companies, also Greek companies. So I can give 2 examples. We have helped ASIC and Acronic with their prototypes. And of course, many of the Greek universities also do prototyping through Europractice. So it took many years to establish, I would say, this platform. We continue to do so, and also under the EU Chip Act, we of course plan to extend our service, in particular to European startups and SMEs. And there are 2 things very important for that. I would say that's on one hand the design platform, which was also mentioned by Thomas in his keynote. Later on, I can maybe give a bit more information on what we exactly plan there. And the second thing is the Pact for Skills, because it will be very important that Europe has the right talent to staff and to step up in this big, I would say, growth in semiconductors. So also there we, as IMEC, hope to play a big role, either through Europractice or through our own program called IMEC Academy.
Okay. Thank you very much. Dear Mr. Kotrotsios, George, CSEM started in 1984, and you have seen it grow to its current size right from the start. Can you give us a brief explanation of what CSEM does and how it contributes to the semiconductor ecosystem? Same question as Romano. And also, what kind of lessons have you learned that Greece might find useful in setting up its own local semiconductor ecosystem?
Long question. Let's start from the beginning. Who we are. So we're a kind of research technology organization, very much like IMEC, like Fraunhofer, like Leti, born in 1984.
Δεν ακούγεται.
So give me the microphone.
Yeah. Thanks. So CSEM is a kind of research technology organization, very much like IMEC, like Leti, like Fraunhofer, born in same year, by the way, like IMEC 1984, from the watch industry to support the watch industry. Actually, we operate as Société Anonyme, anonymous εταιρεία, which is non-for-profit, a kind of public-private partnership, which is in 2 dimensions. One in terms of equity, we belong partly to the Swiss government, 14% to the local canton. In Switzerland, we call it cantons, and also to the industry. 70 shareholders from Nestlé, Logitech, UBS, and several others, Bosch, the Swiss branch of Bosch, Philips, etc. But the main shareholders, which are in our board, is the watchmakers, Rolex, Patek Philippe, Swatch Group, Swatch is Omega, it's Tissot, and these kind of things, and Richemont Group. 2 energy companies, and finally 1 medical company, Sonova, they're making the hearing aids. So this is the equity private public partnership. And this is the financing, which we receive out of 90 million Swiss francs per year, 1/3 by the Swiss government year after year, 1/3 by competitive projects, European and national innovation, another something like 30 millions out of industrial projects, about 400 per year. Majority of them brings new projects, new products. And our mission, which is very important, is not scientific, it's economic. At the end of the day, we need to create competitiveness and jobs, and science is the tool. And microtechnology, microelectronics, precisely these tools comes out of the watch industry. So the continuance of your question, what's lessons learned and where we go, and which can propose, think about the Greek ecosystem. Lessons learned. We made a number of errors. Very interesting lessons learned. It was in the 80s, late 80s. At the beginning, we were making research in semiconductor processes and design. And then at that time, we thought it becomes too expensive. And then at that time, we decided to say, let's focus on design, but not on processes. The other way around than IMEC. It was smart, not smart, I don't know. But at the end of the day, we stay a smaller organization than IMEC, 600 persons. The Swiss industry is happy from what we are doing. We work also globally. But at the end of the day, it's something to think which is the right focus to give. It is perhaps the advice we will give to the Greek ecosystem, perhaps later. What should be the focus, where to go? Make design, strengthen the design, what beyond design, because sustainability between manufacturing and design should be provided. The first thing. The second thing, it goes the local ecosystems. We worked for several years only in things like micromechanics, microelectronics, and we omitted to work for pharma industry, key local industry. We started doing that much later, something like 2010, 2015. It was not very smart not to focus on the key local industry. Now, this was important. Now, what was success factors can perhaps replicate it? I think one success factor was that in our minds, we had here written that our mission is economic, it's not science. You go to the universities are saying that we're going to make beautiful research, be among the best universities in the world. We have excellent people, but at the end of the day, our mission is not to have excellence for educate young people, but going and bring this innovation technology to the market to make new projects. And next point, it is also that we're very lucky to be in an environment which is very good for innovation. Switzerland for 12 years is #1 in the world in innovation. So we're very lucky in being very balanced systems, having big companies, Nestle, pharma, microelectronics, short industry, SMEs, startups, and very good networks and of course education. I think start responding to your question. And finally, just to finalize, chance is a big factor. It happens that the heritage of the Swiss industry, the precise, low energy, and this kind of things, it's exactly what is needed now for IoT devices, making the complex very small, very low energy.
Thank you. A similar question is going now to Victor. From your experience, you've seen Ireland, you're Spanish, you heard about Spain trying to start an ecosystem from scratch. What does it take to build the same thing as yours, an innovative, sustainable ecosystem? What sort of cooperation might be required amongst the relevant players between suppliers and end user industries? And what are the required infrastructures, if any? And with a focus on the Greek ecosystem.
Yeah, so from my work experience in Ireland and Spain, but also Finland, I would say there's, to build an innovative and sustainable ecosystem, you have to focus on 3 key components. The first one is talent, and we are seeing at the moment big shortages of talent. The second one is R&D, to get new ideas, new technologies, and finally scaling up those technologies. With the talent you have created, as well as the ideas and technologies in the R&D. And with the scaling up, as it was mentioned, you can bring an economic impact, not only to the industry, but also to society. For example, in Greece, Think Silicon has become the market leader in all over the world in wearables, and they have shipped their technology to 50 million smartwatches in 2021, and they have been able to do this by creating a joint research team at the University of Thessaloniki, which is investing in new talent, but also on R&D projects, which in some cases, thankfully, they have been supported with government and European investments. Finally, they take these, from these investments, they take these ideas and these technologies and this talent, and they scale it up with new investments at Think Silicon. So in this way, you can build an innovative and sustainable ecosystem, but it's only by joining forces between the government, the universities, and the industry that you are gonna create a sufficient impact. We must remember that the EU Chips Act is gonna mobilize 40 billion euros up to 2030, more than 40 billion euros up to 2030. But this might not be enough, and that's why we need to join forces, because the largest semiconductor manufacturer in the world at the moment is investing more than 40 billion euros per year, every year. So it needs really a joint effort between universities, government, and industry to build this ecosystem.
Very clear, very true. Thank you. I thought we had Mr. Limberis as well on the panel, but I haven't seen him joining. He was going to join remotely. So we proceed without Mr. Limberis.
There is. There is Andreas.
Oh, there he is. Kalimera.
Morning. Kalimera. Can you hear me?
Yes, we can hear you.
Super.
Okay.
Thank you very much for the invitation, and I really regret not being in Athens with you today.
We would like to be here as well, but hey. So, Mr. Limberis, you are the head of sector in the EIC Challenge-based accelerator. Correct? Yes. So, you have a long experience with running EU programs in the area of smart microsystems, bioelectronics, and smart wearables for the last 20 years. Can you tell us your experience, what are the successful ingredients of European funded projects? And
yes,
your experience, what tends to be the return of investment in Europe from those projects?
Thank you for it's a big question, which cannot be summarized, of course, in one sentence. As a biomedical engineer, yes, I have been very much active in all the bio-related electronics, photonics, sensors, all these activities that we funded from early 2000 in the European Commission, the ICT program. And we mainly focused on new business models or new societal models. For example, for health, we have focused very much on technologies that would prevent diseases instead of curing diseases in the hospital. So all these point-of-care systems, all these sensors, all these technologies around the human body has been built in order to prevent, in order to follow up, or in order to make life better, well-being, etc. So well-being applications, etc. So all these technologies have been supported in order to achieve new, let's say, societal goals, and also, as I said, preventing disease, improving healthcare systems, etc. So electronics has played a big role. The programs that I have managed in the Commission are cooperative programs. So we have funded consortia, let's say collaborations between companies, big companies, small companies, research centers, academics. And this, during these 20 years, I would say, in the area of smart wearables, smart textile, micro-nano bioelectronics, the focus was on the system integration. So not only on building the blocks, for example, I would say in fluidics, in lab-on-chip could be fluidics, sensing technologies, functionalization, biofunctionalization, all these kind of building blocks, but what was the big challenge was the interfaces and the system integration. This has been the hurdle of, let's say, the researchers, the engineers, and the industry for the last 20 years. It was to miniaturize, but among all, it was to integrate and to achieve all these functionalities in a small volume and with the different interfaces. So this has been the big issue in electronics, integrated systems, and all these applications going from smart wearables to micro, nano, bio, electronics and biosystems. And what we achieved is a big bunch of prototypes in the lab. So TRL4, I would say there have been many achievements. And the big hurdle was how to get these technologies out of the lab and test it in real environments. This has taken another 10, 15 years, I would say, to come to the point where today in the council where I work, we can fund now small and medium enterprises. So companies that can bring these technologies, this miniaturized lab on chip, for example, or organ on chip, into the real environment and receive an investment from us or a funding for grant of many millions of euros in order to go to the market and to validate this technology. It took, in my opinion, this miniaturization, integration, system integration, and functionalities integrated in such a small volume, 20 years. And we're not yet there. We have not created an economy from these technologies. We just created prototypes and a series of technologies that are mature enough to be validated in real environment, not yet massively in the market.
Okay, so the return on investment.
An investment, I would say, I'm not sure I understood the question, but investment
What
of
tends to
many...
be the return of investment on these European projects in figures? Do you happen to know this?
Yes, absolutely. So I can say that in this, I look on projects we funded in the area of health and nanotechnologies, microelectronics, sensors, etc. In the last, let's say, 10, 15 years, we have spent 500 million euros for these technologies. The return of investment is a lot, of course, of new capacities to develop these technologies, to integrate them. So some pilot lines and some prototypes. Return of investment is knowledge, of course. Return of investment is building the community, making the network working together. There is no financial return of investment from this, but it is a capacity that we have built in order to be in a position today to say that we are at a position to commercialize now or in the next few years these technologies.
So it's not measurable, but it's very important.
As you know, these technologies and these programs are not measurable from that point of view. These cooperative initiatives are measurable from building the network, building the capacities, training students, making PhDs, hire some people to work in the projects. But then this brings to a maturity level and to a capacity level that we can commercialize now and very soon, I would say, in the market.
Clear, thank you. Romano, there was a lot of mention about the chip design platform. I know you're directly involved in Euro practice from the IMEC side. Can you give us a bit of detail on how do you think this design platform would work, whether it's feasible or not, given the number of industries involved?
Yeah. Yes, so I'm involved in the discussion with the European Commission and of course also many other companies and institutes on setting up this design platform that was also announced this morning already. It is not an easy task. So the goal is really to lower the barrier for fabless companies to design, to manufacture their first prototypes and then to scale up and to have a first time right. So because especially in very advanced technology, it's very difficult to set up the design flow. It's not something trivial and many people cannot do it. So what we hope to set up in the cloud is a system where you have different chambers. You have a chamber for different TSMC technologies. You have a chamber for global foundries. You have maybe one for Intel and so on. And in those chambers, you have design flows already pre-set up. So depending on whether you have an RF application or a low power or whatever, you can already immediately start to design. And of course, what was mentioned by Victor also, the ecosystem building is very important. And that's something we have done for a very long time already within IMEC. So at IMEC IC-Link, we don't do this on our own. We have more than 50 partners where we work together with. I would say our most important partners are, of course, TSMC, who does the manufacturing, but also Cadence, Siemens EDA, and Synopsys for the design tools, and so on. Yeah? So it's really a big, and Ansys, of course. Sorry, I almost forgot to mention. So yes, we are working on the design platform. It will not, again, be an easy task, because it might be also that some of the business models that have been going on for many years will be disrupted. And of course, that companies don't like. So we really have to see how we can find a way of working that suits everyone. But in the end, it really needs to come to the benefit of the European, well, semiconductor design ecosystem, and especially the small companies there. So that should be the benefit.
Okay, I understand the complexity. I have one more question very briefly.
Sure.
I know the European Commission wants to build competence centers which will be directly involved with design. These competence centers will have a local nature.
Yeah, correct.
But the design platform will have a European nature.
Correct.
How is it to combine?
Yeah, well, there is also still discussions on that, so I can only tell what I know at the moment, and that might still change. The thing that will not change, indeed, is what you said rightfully, that the competence centers will be nationally. They will also be funded partially by national funding. So there will be a competence center or competence centers in Greece. Most likely, those competence centers will be responsible for the training, the first-hand training of new people, but also the intake of customers, and then to bring them to the design platform or to some aggregators of services like we in IMEC do.
Okay.
Yeah, so that's at the moment how it looks like, but again, it might still change.
Work in progress. Okay,
Yeah.
Thank you. George, besides having witnessed the history of CSEM, you have also witnessed the local history of the Greek ecosystem to what it is now. Okay. Do you see any specific opportunity which, combined with the current Greek advantages and CIPS Act, can quickly boost our position in the global and European ecosystems?
Thanks. Yes, I observed since 2005, 2006, the evolution of Coralia, the whole microelectronic ecosystem here. It was really fantastic what's happening now. It is very positive. I think, for me, the obvious, at least, is strengthen what exists more. That means strengthen this microelectronics environment that exists more. Second is sustainability. We found out that without manufacturing capabilities, sustainability cannot exist. I mean, research and development and engineering far away from manufacturing is difficult. It can exist, but it becomes more and more difficult. So the idea is to create the right manufacturing, whatever manufacturing can be packaging, can be assembling, can be something specific and beyond, or more than more, beyond more, these kind of things, to add on top of microelectronics. And the third, try to focus somewhere, try to identify the errors we made ourselves, try to identify fields that in which the country has capabilities. Perhaps the biosensing, health, agro can be one of these fields, can be other, but my first feeling is that this one is a good one. That's the first thing. And then, of course, using help of external actors, can be organizations like IMEC and like LETI, like us, whatever, but using external support from people they broke their teeth in making these kind of things to accelerate this process. I think this should happen. Reinforce what exists, build manufacturing, and find some target markets in which start developing, of course, growing later during the time. And this should happen absolutely now. It's an opportunity now. CHIP Act is an opportunity to do it, but anyway, even with its support, it should happen. The competitiveness of a country needs this kind of thing. CHIP Act is an opportunity to make it. I'm very happy to see if this kind of thing happens, because it will help Greece to be a kind of additional pillar to European and to worldwide, of course, innovation environment.
mentioned the help of IMEC, so I suppose your Greek is not going to go to waste, your Greek language lessons. So, and Andreas Limberis, is he still online?
Still here?
Okay.
I'm still here.
So, Andrea, for the past 2 years, you have been working with the European Innovation Council, managing funding activities for deep tech SMEs. Can you very briefly tell us how this mechanism, the funding mechanism works, and how can SMEs receive private investment in addition to the grant? Also, we have been discussing within HETIA the possibility of setting up a Greek fund, a European fund that would incentivize venture capitalists in Greece to put more semiconductor companies in their portfolios. Do you think this is feasible? Can the EIC mechanism work for this?
Okay, so as you might know, some of you or many of you, in Horizon Europe, the European Commission has proposed the biggest innovation action ever, one of the biggest public funds worldwide, I would say. It was created in 2020 with 3 billion euros, the EIC fund. So this is part of this big program, the European Innovation Council, 10 billion euros funding for this program, 21-27. It includes three, let's say, instruments mainly. One is the Pathfinder instrument, which is early research in all type of technologies. So Pathfinder is consortia. So it's again a collaborative program for up to 3 million euros per consortium, so early stage research. Then there is the transition. Transition is the second instrument where we try to bring breakthrough technologies from Pathfinder to the accelerator. And then the accelerator, where I work. The accelerator is a particular instrument, very new program. It has started as a pilot in Horizon 2020. It is the continuation of the old SME instrument. The accelerator has every year, let's say, more or less something like 1 billion, 200 million euros. We fund companies that are really deep tech companies, small and medium enterprises only, and we fund them with a grant up to 2.5 million euros to develop and to validate technologies. We speak here about TRL 5 to 6 until TRL 8. These are the innovation activities which we fund with up to 2.5 million euros, 70% reimbursement of these activities, and 30% it is put by the company own. In addition, we invest in the company, so the company can ask for an investment, for an equity, or convertible loan. So it depends on the due diligence process. So the company can ask for a blended finance, as we said. One part is the grant, and the other part is the equity, up to 15 million euros. Even more, if really duly justified, like for example in the next work program, 2023, we have 7 challenges, because I forgot to mention that the accelerator, as the Pathfinder and as the transition, have an open program, so for any type of technology, and also challenges. Next year we have 7 challenges. One of these challenges is the contribution to the CHIPS Act. Now I'm speaking about everything. I will come to your question at the end, Babi. So one of the challenges is quantum computing and chip design and production for 100 million euros. So this is a challenge of the accelerator for 100 million euros. This is the first contribution to the CHIPS Act. And our program, the EIC Fund, will have to contribute to the CHIPS Act for this period 21-27, about 300 million euros. The equity part is provided by the EIC Fund. The EIC Fund is managing the EIC investment. We are working with the European Investment Bank, who is doing the due diligence, all the checks of the company, to see really if the company is eligible, is not bankrupted, who is the team behind the company, etc. So once the due diligence is terminated, the European Investment Bank makes a recommendation, and then we continue with the signature of the investment agreement with the company, as I said. So All this can take, let's say, up to 5 months to sign the grant with the company after the closure of the cutoff, and then a few months later maybe to sign the investment agreement. So I answer the question about what is the accelerator and how we invest and we fund companies, small and medium enterprises in deep tech areas, only deep tech areas. Just to say something which is very important, we do not invest in companies just to keep them in the stage where they are. So we invest in SMEs, in startups, but not to keep them alive. We invest them in order to scale up, to become center, to become unicorn. If this is not the case, if the business plan of the company does not lead to such a scale up, we do not invest in the company, we do not fund the company. Now, about the fund. So, as I said, this fund is managed by the European Commission. It is also managed by an external investor. So there is a consortium, let's say, of this fund. Decisions are taken. Investments are done with the recommendation of the EIB. It is not a vertical investment. It is not a thematic investment. It's horizontal. And then there is a network of VCs with whom we collaborate in order to increase the participation of other investors in the company. We are not the only investor. The ESG fund is not the only investor in the company. We invest first in the company most of the times because we take the risks that no other private investor will take in the company. But this is in order to crowd in other investors and to make really a consortium of investors, a mezzanine, as we said, in order to give the necessary fund and investment to the company to scale up. And this, of course, can, and as for the Greek fund and investment, this has to be seen, has to be discussed. I don't have really, at this moment, a button to push in order to see how this can be possible, but certainly the companies in Greece individually can really apply in our program. I have seen that in the last cutoff in October that we have finished the evaluation now, there have been 12 Greek companies submitted proposals in the accelerator now in October. One of them has been invited for the interview because we have 3-step evaluation, 1 out of 12. Greece is situated for the widening countries, let's say all these countries that are out of the big Central European countries, is situated in the middle. Before it was worse, now it's getting better. People are getting informed about the program. Companies submit more and more. And I think that we need really to inform the Greek community about this program, and companies can really look at the program and submit more and more and have better success. And for the fund, I think it's an opportunity for Greece and Hetia to have a look on the venture capital opportunities that we provide in the council, and to see really how, by discussing together, we can set this and transfer this capacity into the Greek reality, into the Greek community.
Fantastic.
Sorry if I was long.
No, it's fine, and I was not aware of all these tools, so I'm sure most of the companies, small companies, might be interested in this kind of thing. Thank you so much. Thank you all for traveling to Athens for this, Victor and Romano and George. Thank you indeed.
Thank you.